So we're looking at something that looks like alkanes PowerPoint, but it's actually going to feed into cycloalkanes. So this we've seen before in the previous notes. And now it's a cyclo. Anytime you see cyclo, that just means it's a ring. And the smallest ring we can get is going to have 3 carbons. And then we can go up from there. And what this means is, for a cycloalkane, if we think of it as a snake, it's like a snake that's bitten its tail. And by biting its tail, it's wiped out the location for 2 hydrogen atoms. So instead of being CnH2n plus 2, it's just CnH2n, because we've wiped out 2 bonding sites. So we said the smallest cycloalkane will have 3 carbons, so that would cleverly be called cyclopropane. And that's what we have here. And what you see is this really doesn't give us a lot of information. This gives us a lot more information about the structure of our cycloalkane in this case. Now, I guess we're not really making a sausage this time. We're kind of making a weird donut. And so here's our weird donut, and we have 5 carbons in there. And so it must be cyclopentane. So that was pretty easy. Now this is a little bit stranger, so we really have to be careful how we make our donut, which is just a warp sausage. So what we see is this is going to be cyclobutane. So somewhere over here we'd write cyclobutane. Now we don't have 1 bromine, we have 2. So we don't have bromo, we're going to have dibromo. And right here, by now we're getting used to CH2, CH3 is ethyl. So we're going to stitch that all together. So we end up going 1, 1 dibromo. We just decide that that's carbon 1. It's got 2 branches sticking out of it, so we may as well do that. Then we go over here to the next carbon, and that's a 2, and it's an ethyl. The cyclo tells us it's a ring, and there's our butane. A lot going on. You wouldn't want to go 1, 1 dibromo and then go 1, 2, 3, 4, because 2 is a lower address. We can go straight to it. Again, you may want to look at these notes more than once as you process what's going on.